Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday at the Chinese restaurant, this little girl suddenly asked me to explain this question to her. So in this question, we have a spring. When we tie a mass to this spring, it comes to rest at this position here. So this is called the equilibrium position. So note that even at the equilibrium position, the spring is already extended by 20 cm. The question then says that somebody pulls it down an additional 10 cm. When the mass is released, it goes into simple harmonic motion. What is this position? This is the lowest position of the oscillation. And where is the highest position? It should be here. So note the difference between the extension of the spring and the displacement of the oscillation. If you're talking about the extension of the spring, then at the equilibrium position, the extension is 20 cm. At the lowest position is 30 cm. At the highest position is 10 cm. But if you're talking about displacement, then at the equilibrium position, the displacement is 0. At the lowest position is positive 10 cm. If we are taking downward to be positive. At the highest position is negative 10 cm. So back to the question. The question wants the equation that describes this oscillation. Since the oscillation starts from the extreme position, we know that it's going to be a cosine function. If the oscillation started from the equilibrium position, then it will be the sine function. So our job now is just to figure out what is the angular frequency and what is the amplitude of this oscillation. For omega, it's straightforward. We can use the formula 2 pi f. The question told us is 1.59 Hz, so it turns out to be 10 radians per second. As for the amplitude, from the context of the question, we know that the amplitude is 10 cm on both sides of the equilibrium position. So the amplitude is 10 cm or 0.1 meters. So thank you, little girl, for asking this question. I'm always happy to help. Ta-ta!